morning, dear students. Last class we discussed about the meaning of process equation. Generally, the process equation depends upon the process variables, right? Because in any system or in any process, the process variables plays a vital role. So the process variables generally in the industries may be like pressure or levels, temperatures, densities, liquid interfaces, mass, conductivity, like this. Apart from this, there are some other process variables, uh, maybe force or any some accelerations like this. So these are all comes under process variables. When we are experienced with the process, the variables are varying from time to time. So there comes under process variables. The variables means they are changing from one state to other state or time to time. They are simply changing as the time changes. That is the meaning of process variables. Generally, for your industrial instrumentation, the process variables may be you can treat temperature, flow, level, pressure, force like this. These are very important as per your industrial instrumentation, process control instrumentation point of view. We have other also, we will discuss later. And for any process, for example, if you want to control any temperature, so temperature is one variable. So we need some set points of the temperature. So in order to maintain temperature as constant, what are the other variables we want to consider for maintaining the temperature? Say for example. So it describes degree of freedom. Degree of freedom. Degree of freedom means before selecting the controlled and manipulated variables for any control system, one must determine the number of variables permissible. That means if you want to maintain any one set point in the process control system, we need to select other variables that may be control variables or may be manipulated variables. We want to select it. So by the selection of all these control variables and manipulated variables, such that we can maintain constant one variable as set point in the process. So in order to maintain the set point as constant, we need other supporting variables, that all these variables will come under the degree of freedom of any control system. Degree of freedom. Degree of freedom can be described like this. See, the variables you are selected minus the number of variables you are selected minus number of equations governing the system. Governing the system. So such that we have to select it. So for any system, don't expect more number of equations and don't expect more number of variables. What happens if you select more number of variables and more number of equations? It is very complicated system. So you have to select such that the degree of freedom, the any process will follow the concept of degree of freedom. That is the meaning of this. Okay. As an engineer, you have to think over these variables and equations for any system process. Next slide. Next slide, ma. Komali.
Yes, sir.
Next slide. Yes, mathematical model. Zoom it, ma. Zoom it. Yes. Yes. Enough. Okay, ma. Thank you. Yes. So today our actual class is mathematical models, mathematical models for simple systems based on process dynamics or dynamics of simple systems. The heading of the system is how do you express any system into mathematical models? So you are the instrumentation people, you have the subject like control system. Already we discussed in the 2-1 level control system engineering. In that you are familiar the concept of mathematical models or block diagram. I mean, no, mathematical models means you are simply expressing any control system into mathematics or into differential equations, right? Simply you are converting the system. It may be mechanical system or electrical system or pneumatic system like this. Any system, you are able to convert that system into mathematics or differential equations or mathematical equations. That mathematical equations or differential equations, they are simply called mathematical model of a given system. Here also, mathematical model of a simple systems based on the process dynamics means here we have in the process control instrumentation, we have some systems. If you see any process industry or chemical plant, you see what are the systems available. That may be liquid systems, gas systems, thermal systems, or maybe sometimes electrical systems. So any process industry composed of all the systems. Once again, I am speaking. Any process industry or any chemical plant or any industry may be composed of number of systems, number of subsystems like liquid systems, gas systems, thermal systems, sometimes electrical systems, maybe other supporting systems also, no problem. But my point is, the system includes all these subsystems like liquid, electrical, gas, thermal systems. Fine. But the question is, the heading of the today class is mathematical model for the system based on process dynamics. It means that as an instrumentation engineer, you need to convert, you need to write some mathematical equations for the available systems in the industry. You need to convert the liquid system into mathematics. You need to convert the hydraulic system, nothing but liquid system, okay, leave it. You need to convert electrical system into mathematics. You need to convert thermal system into mathematics. Like you need to convert gas system into mathematics. There may be one question: why we need to convert all the subsystems available in a plant into mathematics? The answer for this is in order to in order for simple control system purpose, simple controlling purpose. See, for example, I will tell you, we will explain today, liquid level system. How do you describe any liquid level system? See the diagram. This is this is a chamber. It has two openings. Two openings. First opening is inlet. Water is inlet. Second opening is water is outlet. Water is outlet. See the inlet water and outlet water, and in between there is a controller. This is called valve. This is called valve. Right. So the water inlet can be controlled. That means QI is the inlet, water flow rate. Say QI is inlet flow rate. And what is Q naught? Q naught is outlet flow rate. Outlet flow rate. And H is level of liquid in a tank. This is a tank. This is a tank. In the tank, the water level is small h. And there is here, see the diagram carefully. There is a wall. There is a wall. That is, we are describing to capital R. This wall will give to the system like resistance, like a resistance. And in this tank, the tank surface will give you the capacitance. Will give the capacitance. And see that this is a complete liquid system. Liquid system can be described like this. So in this liquid system, we want to convert this total liquid system into mathematics. Go to the next slide. Next slide. So how do you convert this total liquid system into simple mathematics? Simple mathematics. So there are two possibilities. There are two possibilities. From the system, we are expecting two parameters. Two parameters. One parameter is resistance, other parameter is capacitance. Right? One parameter is resistance. What is the resistance? When you are controlling the wall in between inlet and outlet, it gives the flow. The flow is going to be controlled. This flow in horizontal direction will give you the resistance value, the resistance, the resistance of the wall, right? And is a tank having some surface. It gives some level, then some level. So maximum level and minimum level. It creates two parallel plates. It creates two parallel plates. Yes or no? So that it looks like a parallel plate which gives us capacitance. Gives us is capacitance. Okay. So this liquid system having two parameters. One is resistance and other one is capacitance. You tell me what are the mathematical parties available in governing in the liquid system? I will tell you. QI, input flow rate. Number 2, output flow rate. Number 3, head in the tank, level in the tank, small head. Number 4, the wall resistance, capital R. Number 5, the capacitance, capital C. Capacitance, capital C. And one more parameter we are describing in the system, small u. What is u? U refers to, it is nothing but uh, down head. Down head. Down head means don't down your head. Hello. Don't down your head. Down head refers to water level when it comes to as outlet. Water level when it comes to as outlet. That is called down head. Downstream head. You can call downstream head. U refers to. See, these are the mathematical parameters are available in a liquid system. Fine. But what is our aim? Our aim is we need to convert, we need to describe the total liquid system into simple mathematics, simple equations. The equation may be in terms of in terms of u or in terms of h. You can write the mathematical equation. Mathematical equation. See, the liquid system generally describes what are the parameters available in the liquid system: flow rate QI and Q naught, and head and capacitance C, resistance R, and time factor C, and time factor T. Time factor T. So these are all available in system. So we can write mathematically right here, starting from like this. So the QI minus Q naught, difference of this flow rate will give us head, depends on head. Yes or no? If you apply flow rate, if you apply flow rate very highly with high velocity, what happens in the tank level head? It is increases very high. The level in the tank is increases. If you apply slow flow rate, the level is slowly rises. Flow rate is high, head is high. So what is my point? The flow rate proportional to head. The flow rate proportional to head. Head means water level in the tank. That's the meaning of this. So we are describing like this. Qi minus Q naught can be proportional to dH by dt. Rate of change of the head value. Rate of change of head value. Very good, ma. Okay. So Qi minus Q naught equals to proportional to dH by dt. What is the meaning of this sentence? This word, the flow rate is always proportional to head value, water water level in the tank. That's the meaning of it. Fine. And I am writing like this. I am removing the proportional word. I am writing equals to. As you know that the tank surface will give us capacitance value. So I am writing Qi minus Q naught equals to Qi minus Q naught equals to C into dH by dt, where C nothing but capacitance, tank capacitance, surface capacitance. Then I am writing Qi equals to C dH by dt plus Q naught. Fine. And what is Q naught? See in the diagram, Q naught is nothing but output flow rate. Output flow rate. Q naught nothing but output flow rate. So the output flow rate will give us, depends on this output flow rate, depends on tank head and downstream head. The Q naught output stream, outlet water stream flow rate depends on tank head and down head, downstream head. So I am writing like this. Q naught equals to H minus U by capital R. What is H? Small h? Tank head. What is U? Downstream head. Water outlet from the tank, isn't it? So that is called downstream head U. And what is R? Resistance provided by the control valve. That valve in the tank. So Q naught is writing like this. Now substitute Q naught in the QA equation. QA equals to C dH by dt plus H minus U by capital R. Fine. Again, what can you do? Multiply both sides by capital R. You may get the equation like this. R into QA equals to RC to dH by dt plus H minus U. Fine. And rearrange the equation. R into QA plus U that side. RC into dH by dt plus capital plus small h. Right. So you consider RC equals to time constant. RC equals to time constant capital T. We are representing like this. RC equal to time constant. We substitute this T in the above equation. You can write Q R into QA plus small u equals to capital T dH by dt plus small h. Fine. And this is the mathematical equation we have. And what can you do? This is enough for you. This is enough for you, but you need to express the equation in terms of H or in terms of U. That is your wish. Why we need to express? If we express it, you know the relation between H and other parameters, and you know the relation between U and other parameters available in the liquid system, so that you can control the variables, you can manipulate all the variables such that you can maintain any one parameter as constant in the system. So suppose I want to maintain H as constant, I can do it. Suppose I want to maintain U as constant, I can do it. So how can I do it? If I know the corresponding relations of H and corresponding relations of U, which are depends on other manipulated parameters. So that I need to express the above equation into suitable form. How can I express the above equation? Simply express the above equation into by applying Laplace transform, so that I can get H. H relation and U relation. See that. Apply Laplace transform to the above equation. You know that R is as it is. Small qi is a variable. What are the variables that comes under capital U, that comes under capital U of S, but it is representing small u of S, but we need to write capital U of S, capital U I of, I'm sorry, capital Q I of S. We have to write, but here he is writing Q I of capital S. Of course, it is also correct, no problem in the process side. Okay, we are converting this into like this. Q into R into Qi of S plus small u is represented by capital U of S equals to T into, see the derivative factor. This derivative factor dH by dt can be right S into H of S. S into H of S plus capital H of S. So we are combining, we are writing like this. Arrange this equation, write the H of S, you may get like this above equation. So I have right now H of S. Right now I have H of S. H of S. So how can I write H of S? Like this. R by Ts plus 1 into Qi of S. Yes. Plus 1 by Ts plus 1 into U of S. Right. So uh, uh, I'm representing the above mathematical equation in terms of block diagram. I can write the same equation. What is the output? H of S is the output. H of S is the output. See the diagram? H of S is the output. H of S is the output. See the diagram. Based on the above equation, I am constructing the block diagram. H of S is the output. And what are the inputs? We need a summer. We have two inputs, U of S and Qi of S. How do I connect the two inputs? I cannot connect two inputs directly. We have some transmittance value. What is the transmittance for U of S? The gain transmittance, the gain value. What is the gain value for U of S? U of S is multiplied with 1 by Ts plus 1. So I am representing the gain in a simple block. By applying some U of S as input, the output of the gain connected to input of a error detector. That is over. And we have other input to the error detector is from Qi of S. Qi of S has multiplied with some transmittance again R by Ts plus 1. So that is multiplied with Qi of S. So the output is given to the error detector. Now I have U of S equation. Now I have H of S equation. So the H of S equation I have like this as above. So how can I know? What can I do with this? I can do with this. If I control the H value, I need to control the remaining parameters. So that is a mathematical part. Or if you don't want H of S, or you want other variable, you go. You show me the other slide, ma. Satyakomali. You show me the next slide.
Yes, sir. Yes, sir.
Yeah, take this. The same system, you come down the last point, in the same slide, last point. See, if you want to control, if you want other H of S like this, H of S is like this. Yes. Other, for, show me the diagram in the same slide, diagram. Yeah, this system, see this system. So we have two inputs. But we need to control H of S. We have only one input. QI is input, inlet, and here other input. We have other input. Two inputs into the tank, such that we need to control H value. So that what is the H equation? How it depends? Come to the last equation. Down Jema. Down. Yeah. Ah. Then, h of s equal to, see this. I have other relation. I have other relation. So my point is, in a liquid system, we have number of parameters, of course, but we need to control one parameter that is called process variable head. Head is the process variable. It is also called a control variable. We need to control it. We need to control it, right? So how it is possible? It is possible by knowing a mathematical equation of the concerned system. Okay, that is today our class. We are expressing a simple liquid system or hydraulic system into mathematics, such that we know that how can I control a suitable control variable or a set point or a set, how I can maintain a set point in the system. Tomorrow we'll see uh, other systems. Okay, if you have any doubt, don't worry. I will provide the same. Class in the YouTube, and I will give the YouTube link to all your class members through your CR. Okay.